Hello, this is Joe Garrett with VaultSync Solutions, and I wanted to show you today the example of CORA, which is a geometric language model similar to AI and LLM. It is trained in a way in the sense of mathematical formulas that look into data, but there is no inference or training engine or any of those things that you would count as normal parts of current AI systems. Our solution here cannot drift, cannot hallucinate, and can only use what information and knowledge it has in order to give a full response. It does this using a browser WASM WebAssembly for the user interface and a routing module through a GDBSio driver, which that driver has a full multi-million seed corpus or knowledge system of about 5.1 million seeds, which is roughly order of magnitude around 500 million words. And those words are parameterized against a multitude of different sets. Now, there's still a lot to be done, but I wanted to give you a direct interface to see where CORA stands today. There's no client side sharding, there's no downloads. This is going to be direct. So we're going to ask a few things and walk you through exactly what CORA can do.
I'm CORA. I run entirely inside your browser tab. One WASM instance holding the GDBS toroidal mesh, the MS1 moral gate, the KSP1 Kolmogorov processor, and the mesh forward pass. No server, no network call on chat. Every question runs the same pipeline, moral gate, complexity, mesh traversal.
So as you see, she does have text to speech, and she can pull from all 5 million seeds. So one of the things that we're going to do is I'm going to say hello.
Hey there. Mesh is warm, nothing snarled. What do you want to find?
So as you see, we ask her a question and she responds. So now the thing that I'm going to do now is I'm going to ask how many, and this is a traditional failure of most AI systems and large language models, how many R's in the word strawberry?
There are three R letters in strawberry.
So that is tuning, and obviously it understands what that means. So the next thing I'm going to say is, my name is Joe Garrett.
Got it. Nice to meet you, Joe Garrett.
And now I'm going to ex- tell me about GDBS.
Geometric database system matches existing gene GDBS schema exactly now with Hebbian learning via symlink, reinforcement activation trace entry records which symlinks fired during traversal.
So, what else is there? Tell me about GDBSIO.
gdbsio is my native driver and access layer, the I/O surface between callers and the GDBS substrate.
So, these are some continual conversations that are occurring. And again, right now, this is just search. Um, and there's a lot more to it than just search. It can generate information and it has a full auditability trace, as you can see down below. You can see where there are connections and where there's not connections. Down below, as one would identify, the geometric search did connect a banana to an orange because of how they're related, but also you can see that there are multiple different other connections that it made prior. Now, these are different probability layers that were surfaced and that identified that they may be, in fact, something usable. And again, my point here is that CORA is a system that is growing and has a capacity to do um, what current AI LLM systems are doing today. I am in the process of building an entire solution. I have been working on this for some time, and yes, it does have code and JavaScript and C Sharp and many other avenues. And it is not just a search engine. As I can ask it, can you tell me about black holes?
Please review the black hole output from GDBS below.
And so it will have the capacity to query and communicate directly with GDBS, which is another platform and development solution that we provide as a company. With that being said, we also have been working nonstop in the idea of providing a direct conversational flow based on the session of the user that is currently engaging it. So, how are you doing?
Okay, I'm up. No drift. No gaps I'm aware of. Mesh responding clean.
So
What's on your mind?
in this, we see that we made a driver request. We did a 873 lookup, 873 millisecond lookup, and within that we scanned 241,259 seeds, and this is the generated response. If we go through our trace, we can see the multiple different things that were the choice from the ingested information. These were the choices that were presented, and if we look at each one of those choices, none of them were the one that she generated. Now, she's framed the response based on what she understands, it understands of its technology. So, I want to then, since I asked, what are you wearing?
That doesn't apply here. I'm digital. If you want a system side answer, whatever the mesh curvature is doing at the moment, that's what I'm in.
So again, the idea is that she made an implied or it made an implied connection between the geometry and scored an appropriate response that answers to the question. And we can see down below that there are scoring recommendations and verified inputs that literally identify what are the potential possible answers that could come back with whatever response was what was ingested, and we're making a Bayesian probability of the answers that we have to generate a response. Now we use what's known as Kolmogorov semantic complexity and a Bayesian translation protocol, along with a moral gate and a retrieval system that is applied to what I have termed as a synaptic network, a virtual synaptic network. These are uh, essentially a peak and valley system of scoring across an entire mesh substrate. And within the peaks and valleys, I can store based on particular points inside of that. I can store, hey, this has got more attention or less attention, and in these things, I can find information that is related by those attention spikes. And then, lastly, of course, we do an evaluation of the intelligence of the user, not in the sense of an IQ, but in the sense of uh, arithmetic and creativity, and two other areas. And those two other areas, type 1, type 2, 3, and 4, we plot the user as they move through the intelligence regions whenever they're communicating with the user. And of course, we evaluate that so that we can return whatever might be appropriate to the specific response of the user. Anyway, that concludes the product demonstration. My apologies for taking up your time. If you have any questions or concerns or just want to test this out, you can go to cora.getfaultsync.com. And again, it is based on GDBS. It is available today, currently has no cost whatsoever. We encourage you to take a look at it. It does. It is in its infancy, and it still has a lot of growth. And every day we are working on this, and our goal of course, with this particular application is full auditable control using geometric language model as the primary solution and geometry as the substrate that we're using along with GDBS, and to have integration between the two so that you can do physics in CORA or you can communicate through GDBS back to CORA so that others may benefit from the physics that you may be doing. Again, I appreciate your time. You can contact us at sales@getvaultsync.com or go to gdbs.getvaultsync.com, getvaultsync.com, or cora.getvaultsync.com. You have a great day, and thank you.